Oh, hey, we're recording now.
Beautiful. All right. So problems 1, 2, and 3 share the same body diagram. We're just going to find different components inside this body. So, craps. I forgot to write the feet. Feet. Shoots. Okay. 8 feet. That is also 8 feet. This is 6 feet. 12 feet. And 12 feet. All right, cool. Just gonna make markers right there, right there, right there. All right, so A to B is 8 feet, B to C is 8 feet, C to D is 6 feet, D to E is 12 feet, E to F is 12 feet. All right, cool. So we have 3 forces in here, 3.7 kips down, 4.1 kips down, and 2.5 kips going up. So the first problem is asking for what is the vertical reaction at point F? So we're trying to find reaction in the y direction at point F. So first we should just draw in all the reaction vectors. So for pins, we have 2 vectors. We have an RXA and an RYA. Because it's a pin, there's two reactions. And how many reactions do we have in a roller?
I believe we only have one, right? The circular rotation.
We only have one reaction for a roller, and it's going to be perpendicular to the surface of the roller. So and the reasoning is, we're just going to go over this again. There's no restriction of movement in the x direction. So there's no force pushing it back because it's a roller. You can think of it as like a beam on a cylinder. Like, it's not going to go down, but it can go left and right. It's not going to go down because there's a reaction going up, and it can freely go left and right. All right, so there is RXA, RYA, and RYF. Cool, so let's start off by taking summation of moments. Start with the x direction. Summation of the forces in the x direction, assuming right is positive. So we're going to get 0 equals RXA. And that's positive because the reaction is going to the right. Is there any other forces going in the x direction?
Negatory.
Right, so we have RXA equals 0 kips. Beautiful. All right, 0 kip. Cool. You didn't need to do that problem because all you got is 0. There was really no reason to do that, but go through all the steps. Summation of forces, and let's do the y direction now, assuming up is positive. So I have 0 equals, there's an RYA right here. Is that positive or negative?
Wait, which one? I didn't see it.
RYA.
RYA?
Yeah. Is that positive or negative?
Positive if it's
Positive.
going up.
Positive, it's going up. 3.7 kips. Is that going up or down?
That's going down.
So that means it's negative.
Negative.
We have 4.1 kips, that's going down, negative, minus 4.1 kip. And then we have this one, 2.5 kip, plus 2.5 kip because it's going up. And then we have RYF, which is again pointing up, so it's plus RYF. Cool. So we're going to simplify this real quick. 0 equals RYA plus RYF. So we have all the unknowns, and we're going to add together these known values. Oh, calculator here.
5.3. Negative 5.3.
4. Yeah.
Right, negative 5.3, beautiful. Minus 5.3 kips. All right, so now we just move this to the other side. So we have the unknowns on one side and known values on the other side. So this is going to be RYA plus RYF is equal to 5.3 kips. Basic algebra, we just got this coefficient to the other side. All right, everyone understand? Everyone follow? Cool. So we're just going to keep that in our backlog because we don't know what it is. We don't know how to use it yet. So we're just going to keep that there until we can figure out something. All right. So now we're going to move on to summation of moments because that is the next step. That's just one more thing that we can take the summation of. Summation of moments. Well, we're gonna obviously counterclockwise is gonna be positive. Where are we gonna take the summation of moments at?
F.
E.
D. A. No, not A. F.
All right. What does everyone think? Are we gonna take it at A or F?
I would say F.
F.
Yeah, I agree with F.
I agree as well.
All right. So you can actually take the moment anywhere you want, but since everyone said F, we're just gonna do it at F.
Wait. My reasoning for F was that there's only one reaction force on it. I don't know if that's a good reasoning.
Yeah.
See, that was my reasoning.
Let's actually go over that real quick.
See, my reasoning for F was since it's a roller and you're showing me that the arrow is moving in a circular direction, I'm assuming that it's meant to be rolling. That's why.
All right, so let's just go over that real quick. So at A, how many forces are pointing at A?
Dos.
2.
Two forces are pointing at A. How many forces are pointing at F?
Uno.
1.
1. RYF.
What about this boy?
Oh, yes.
RXA. RXA. That's
Oh,
also
zero.
pointing at F. See how it goes through the entire body? RXA hits all the points. It hits A, B, C, D, E, and F. So there's actually two forces pointing at F. There's actually two forces, RXA and RYF. So yeah, just remember the force vector, just extend it all the way through the body to see what points it hits.
Not gonna lie, I forgot about that.
Yeah. Anyway, so let's just take it at F because you all seem to like F. Summation of moments at F, assuming counterclockwise is positive. All right, 0 equals RYF. How far away is that from F?
0.
0 feet. So let's just ignore that. 2.5 kips. How far is that away from F?
12.
12.
And is that positive or negative?
It is negative because E is going up.
No. It would be going.
Yep.
Wait, it's positive. Wait, it's going. You said positive, right? Or you said negative?
I say it's negative because it's going like clockwise. So because E it's going up and that's gonna circle around it. Yep.
Oh.
Clockwise.
Yep.
It's going in the
forgot.
clockwise direction. And we're saying counterclockwise is positive. So yes, this is going to be negative. All right.
I got confused for a second there.
All right. So now we're just going to move on to the next one. 4.1 kips. 4.1 kips. How far away is that from F?
24.
24 feet. And Positive or negative?
Positive.
Positive, beautiful. Counterclockwise around F. Remember, we're taking the first summation of moments at F. All right, 3.7 kips. Is that going to be in the clockwise direction or counterclockwise
Same like,
direction?
Counter.
which one? B? Yeah, it's the same like B.
All right, cool. It's counterclockwise, so it's going to be positive, plus 3.7 kips. And how far away is that from F?
8, 6, 14, 24, 38,
26.
38.
38 feet.
Yep.
8 plus 6, 14 plus 12, 26,
26.
and then plus 12, 38.
Oh, I didn't see it. I forgot the other 12.
All right, maybe I should just make those stronger. Bam, bam, bam.
You want to change the color maybe?
Right,
Or
that's probably
red. Yeah.
Yeah. So we're just gonna divide divisions right there. All right, cool. And then there's this RYA. We don't know the value yet, so we're just gonna put in RYA. Now, how far away is RYA from F?
All of them together. It's 8, 8, 6, 12, 24, 38. 38 plus 8 is gonna be 46.
46 feet. Positive or negative?
Negative.
Negative. And there's this RXA force that we also have. And we
Yeah.
already went over this, but how far away is that from F?
It's the same, 46.
No. It's 0 away.
Oh, 0. Yeah, 0. Yeah, sorry.
Remember, it's pointing straight at F, so
Yep.
it's not like some distance away from F where it's
Yep.
like perpendicular. It's pointing straight at it.
Yep.
I think I already went over this, but let's say you have let's say this is the beam, this is F right here. You have a force right, so we're taking the summation of moments right here. So this is RYA, right? But this is RXA. See how it's pushing directly against the beam, so it won't pivot around F. All right, so we can that's gonna be 0 feet. So just gonna take that away. All right, we're gonna solve for everything. So pull out a calculator and just plug everything in, times 12. Actually, yeah, we don't need that. That's 12 plus. All right, what did everyone get for these 3 terms?
I got negative 30 for the 2.5 times 12.
Okay, negative 30. And it's going to be in kip feet. So we have a kip value and we have a foot value. Okay. And then going to have this one, which is 4.1 times 98.4 kip feet. And we have this term, 140.6 kip feet. We've got a foot right there. And then minus RYA for 6. We're just going to move that to the other side. Just going to add it to both sides. So it's going to be positive RYA times 46 feet. Okay. We can just add all this together. So it would be negative 2.5. Or wait, yeah. So 30. We're gonna get negative 209. Wait, gonna get positive 209. Yeah, okay. Get positive 209 kip feet. Is that what everyone got? Okay.
Yep, I got 209.
All right, and then we're just going to divide both sides by 46 feet. 209 divided by 46. And you should get around 4.543. Cool, so now we know RYA is 4.5543. Look, that's a terrible 4. 4.543. Cool. Is that our answer for number 1?
No.
No.
Right. So I have this. So we're looking for RYF, and we have RYA. This equation right here has RYA and RYF, so we're just going to plug into that. It's going to bring that down. RYF is equal to 5.3 kips. 5.3 kips minus RYA. Jeez. RYA. And RYA we have is this term right here. So we're just going to plug that in. RYF equals 5.3 minus 4.543. And you should get 0.757 kips. Yep.
Oh wait, can you I know you just switched out that 4.543, so that becomes negative right there.
Yeah, so see how this is a positive term right here? We're subtracting RYA. So this would become, oh my God, I hate you. Zoom is being a dummy dumb. So RYA is a positive term, right? But you're subtracting it, so it would become 5.3 minus positive 4.543. Does that make sense?
Yeah, it does. I was just like, wait a minute, because I was putting it on here, I was like kind of confused for a second there.
Okay. So cool. So RYF is equal to 0.757 kips. Anyone not understand?
So far, it feels like it's just the same type of equations we've been using, just applying it to this.
Yeah, it's literally the same. This is so boring.
the cleverest homework is boring.
Yeah, I will say it.
Except this time there's shrimp involved, right, Ali?
I already ate all my shrimp. All I have is rice left, but there's so much rice.
Actually, I do. These are my last 2 shrimp. All I have is vegetables after this.
All right. So good to move on to the second problem. Cool. So I'm just going to put this here as well. RYA is equal to 4.543 kips. Oh God. Paste there. Can move that here. Cool. And that's 0 kip. All right, I'm going to do something weird real quick. Okay, recording. Okay, so now we're going to move on to number 2. All right. So I'm just going to move that off to the side. Now, so number 2, we're looking for the internal shear point at point C. So it's asking for interior reaction forces. So we're just gonna cut it at point C, gonna cut that. And so we're just gonna have two halves. We're gonna have this half. And we're gonna have this half. Yeah. So you have two halves of the same body. Which one should we use to solve for internal moments? Internal
Right one,
shears.
because we have RYF.
Okay. We can actually take either one because it's
Also have RYI.
balanced. Sorry, what was
Wait,
that?
wait. Oh, we also have RYA, right? That could also work too.
Yeah. So we can actually take either one because these values add up to these values. They're the same. So it doesn't matter which one we take actually. So I'm actually going to take the left one because there's less forces. And I double checked with both sides. It doesn't matter which one we solve for. So we're just going to solve for the one on the left. So we have the axial force, we have the shear force, and we have the bending moment. So axial force is P, shear force is V, and bending moment we're going to use M. So how do you differentiate these? Just a quick review. Shear force is kind of like bending force, but not really in a sense. So we have a body. The shear force makes this body go like this. So it's gonna be sort of this shape. See, all the planes of the body stays in the same orientation. So I just have some Legos here. So let's say we have a 5 Lego body. Just gonna put that together real quick. Can everyone see my camera?
I can.
Yes,
Alright.
I see the Legos.
Cool. So we have let's say we have this five Lego piece, and we're gonna apply a shear force to it. Down the middle, going down. So that is the shear force. You see how all the blocks stay vertical, and they just get displaced, right? Cool. But now there is the bending force. The bending moment. So what that does is that creates this sort of shape where all the planes have rotated. So you see how they're not all in this pointing in the same direction. So it'd be the same as taking this Lego thing and then bending it like that. You see there's like a slight bend to it. And like the Legos aren't like moving anywhere, they're just rotating in a sense.
See, listen, I always understood a shear to be like this, where like it's in the same spot, but it's like cracked in the middle, and it's just like they're still standing still, but it's just sheared in the middle like that.
Yeah, so that would be sort of like this.
Yeah.
So you see how in here there's these two forces on both sides. So what you have there, Santos, is we have this. There's a force going this way and a force going this way, and it becomes this sort of shape. Right? And then that can break, and then it just breaks off sort of like this. I believe. Sort of like that, I'm pretty sure. Not 100% sure on that, but this is like the shear force that we're going over in class. Does that kind of make sense?
Oh yeah.
Okay. All right. So and then just real quick, axial. Probably don't need to go over this, but axial to forces, and then it just gets compressed. So see how the planes are further apart up here than they are down here. It just mush it all together. All right. Beautiful. Okay. So now we're gonna look for the shear force at C. So we're looking for this vertical force right here, and this is more realistically pointing straight at C. Just notation we put on this. You put it on the side. So just for notation purposes, you point it directly at C. So we can now, that's really big. We can now take the summation of forces in the y direction, where up is positive. So we're going to have 0 is equal to, there's an RYA right here, which is 4.543 kips. And it's going up, so it's positive. We have this 3.7 going down, negative. And then we have this V, this shear force. Could put these at C. We have this shear force that's going up, so it's going to be positive. Let's see. Right. So now we're just going to move the shear force to the other side and solve for shear force at C. Very simple. Okay, and then you end up with 0.843 kips. Right? Everyone understand?
Yeah.
Cool.
Roger, Roger.
So VC is equal to 0.843 kips. Cool, that's number 2. So
And
just like,
sorry,
yeah,
quick question. So
yeah.
for the shear one, you don't really care about the distance, right?
No, so it's sort of like taking the summation of forces in the y direction, in like the y direction. Because remember when you take summation of forces, you don't care about the direction. Remember when we did the first one, it's sigma f, and then if they're pointing up or down. When we take the moments, then you have to worry about distance.
Okay, thanks so much.
Yeah.
Wait, I have a question.
Yeah.
You said that you moved VC to the other side. Wouldn't it be a negative 0.843?
Oh, I hate this. This is stressing me out.
Yeah, I believe it would be yes. Either the
Yeah.
B, the answer. So.
Yeah. God damn it. Oh. Okay. So yeah, it's negative. Oh gosh. I thought I double checked it.
It happens. Stop beating yourself up.
Hey man, no problem.
All right, VC is equal to negative 0.843. God, I hate my life. All right, we'll be fine. All right. So kips. So yeah, so negative 0.843 kips. So what does that mean? That means it's just pulling down. So you see how this force is going up? If it was a positive force, then it would be pushing up the entire body. So let's say if this was positive, then the body would be going up. But let's say this is negative, it would be actually pulling it down. So it's essentially the same thing as this, but if it was positive. So it's still going in the same direction. So yeah, it's just 0.843 kips going in the down direction. So if you do write positive 0.843, make sure your shear force is pointing down. All right. Cool. Any more questions? All right, cool. We're gonna move on to take the summation of moments at C. So now we're taking this boy, the bending moment at C. Yeah, that's what it's called. Bending moment at C. So now we're just gonna take summation of moments at C. It's essentially the same thing except we're doing moments now, all right? Counterclockwise is positive. Right, all right. Okay, so we're gonna set that equal to 0. All right, so we're just gonna start from the left. RYA, gonna have a 4.543. Geez, 4.543 kips times, because now we're taking summation of moments. Remember, we have to take a force and a distance. So how far away is that from C? Taking it at C, how far away is that from C?
16 feet.
16 feet. Positive or negative?
Positive.
Positive.
It is positive.
Actually negative. Because RYA
It's going up?
going clockwise.
Oh, yeah, yeah.
Right,
sorry.
right. It's the moment. It's not
Yes.
just that it's straight, but it's going to circle.
Okay. Yeah. You guys are having me doubt myself now. All right. 3.7 kips. 3.7 kips. How far away is that from C?
8 feet.
8 feet. Positive or negative?
This one's-
Positive. So it's going down.
Positive. So it's going
Yeah.
down. So see how it pivots or rotates around C, going in the counterclockwise direction. And then we have to add this moment at C, this bending moment at C. So that's actually going to be negative because the way I drew it, it's going in the clockwise direction. Minus M sub C. So if I drew this,
for a second.
Huh?
Someone is asking if it's over yet in the group me.
Are they? Oh, shucks.
I can respond to them real quick. What are they saying? Who?
Oh,
Is it over yet? No, it's still going. No, it's still.
They don't know we migrated to Teams.
I'll send them the link from Discord. I got it. Because didn't Edison make it so it's just open, right? That you can just join.
Yeah.
link on Teams. Okay, perfect.
All right. So, frig. So minus MC, everyone knows why we subtracted it, right? Because it's going in the clockwise direction.
Right.
Yes.
All right. And just another thing, just to further iterate this. So this is a bending moment right at C. So this is occurring right at C. So it's important that we took the summation of moments at C. Because if we took it at A, then we can't really take this bending moment into account. Remember in the first problem set, you had it was like sort of the hangman problem, and they gave you a moment, and you had to take the moment at that point. So this is kind of like the same thing. We have to take the moment at C, summation moments at C. Right. So MC is equal to negative 4.543 times 16 plus 3.7 times 8 feet. That would be equal to, no problem. No. That'd be equal to negative 43.096 kip feet. Right? So because we're finding a moment has to be a force and a distance, so that's why I have kip feet. Everyone follow?
Yes, sir.
MC is equal to negative 43.096 kip feet. Right.
So yeah, I think we got to remember to make sure to put kip feet, because I swear he's all about that too, putting the units correctly.
So yeah, make sure you guys know your units. Use kips for shear force, axial force, reaction forces, normal forces, and use kip feet for moments. So just an important thing to remember. Right? Are we all good?
Yes, sir.
Roger, Roger.
All right. So just for fun, I'm just going to show you that it doesn't matter where you take which side of the thing you take, because it's in equilibrium. So I'm just going to do it right here real quick. So I'm just going to take the shear as well. Just point that down this time. So 4.1. So we have the shear plus 4.1 minus 2.5 minus 0.757. So it's just 4.1 minus 2.5.
Oh, you're taking it on the other half, right?
Yeah, so it's B plus 0.843. So B is equal to negative 0.843. That should be right. Yes. Yeah. So negative 0.48.
Right. The shears are the same, right?
Yeah, they're the same.
Correct. Yeah.
Yeah. Okay. I'm overthinking. Jesus.
Oh, yeah.
And
You're good.
then
Yeah.
and then 4.1 times 6 feet. That would be negative plus 2.5 times 18 plus 0.757 times 30. And then you would also get $43.11. And I rounded, so it's the same. See how they're the same. All right. We're just gonna move on to question 4. Cool. Everyone, just follow and get 1 through 3.
Yeah. We
Yes,
got
sir.
it.
All right. Beautiful. So now we're gonna do number 4. So this one actually doesn't come with a picture. Tells us, given a tower, I'm not gonna type that out. Given a tower that is 300 feet tall, right? Subjected to a lateral wind load of 500 pounds per linear foot, PLF, that's what it stands for, was internal bending moment at the base.
Want to draw it out?
We will draw it out. Very simple, very simple. We have the building. Okay, and this is, geez, crikey. 300 feet tall. Yep. And then we have a 500 pounds per linear foot lateral wind load of 500 pounds per linear foot. So I'm just gonna draw that out. I don't know if there's a convention if I'm supposed to like draw it the other way.
I mean,
Yeah.
it's just like a line load, but sideways, right?
Yeah.
Okay.
I just don't know if this is supposed to be going up or down. Anyway, so we have 500 PLF right here, and we're going to find the internal bending moment at the base of the building. So I'm just going to simplify this. So we literally have a line that is 300 feet tall. Geez, 300 feet tall, and then wind load of 500 PLF. Cool. And we're finding the bending moment at B, at the base. So I'm just going to call this A. I'm going to call this B. We're just going to find the bending moment at B. Right. So this is attached to the base, right? This is the floor. So now we're going to cut it right at the floor. So we're left with literally the same diagram. A, B, 300 feet, 500 PLF, going in that direction.
So it's just like the bridge where we cut it and then we look at it from that other direction, right?
Yeah. Yeah, so we have the axial force, we have the shear force, and then we have the bending moment. Right, so we're literally cutting it right at the base. We still have the entire building, but now we have these internal forces that's at the base. So it's very simple, unless I didn't overthink this, or if I oversunk it, I don't know. Right, so we're just going to take the summation of moments at B, right here, because this is where we cut it. And this is where we drew the moment, so we have to take it there. We're going to assume counterclockwise is positive. So we have 0 equals MB, that's positive, because it's going counterclockwise. And we have this force, 500 PLF. Now, this is a linear load, but we need a moment, which is a force and a distance. This is a force divided by a distance. So let's first get it to a force. So we're going to multiply it by distance. So we're just going to get how strong this force is. So it's just 500 PLF and it's spread across 300 feet, right?
Yeah. So it goes across the whole 300 feet, right? Yeah.
The entirety of the 300 feet. So 500 PLF times 300 feet. Now we have it in. Now we have the units in terms of not kips, pounds, which is a force. But we're looking for moments, so we need another distance. So now we're just going to take the average force right here and consolidate to one point, which happens to be right in the middle of the linear load. And how far away is that from B?
150.
150 feet. Right. So I'm just gonna do that. So this is essentially what we did. So 500 pounds per linear feet. That's spread across the entire 300 feet. So I don't really know a good way to do it. So we're just gonna consolidate this down to 1 point, right? And the average of a line is the middle, right? That's why it's called like the middle. So we averaged it down, this 500 PLF, to 1 point, which is this 500 PLF times 300. 500 times 300 pounds. And because we consolidate that into the middle, we can now multiply that by this length, which happens to be half of this entire length, which is 150 pounds. That's essentially what we did. Consolidate down to 1 point and then measure the distance. That's where these two numbers came from. My times 300, which is the entire facade of the building, and then the 150, which is the average distance from the base. I'm gonna multiply this all out. Gonna move the moment to the other side. Wait, okay. Is this going to be positive or negative? Right, I knew I was forgetting something. Positive or negative?
So it's around point B. So if that line load goes, it's going downwards. That's clockwise negative, I think.
So yeah, it's going clockwise. Remember, when we consolidate down to 1 point, one force is pointing in this direction, and then it goes clockwise around this boy. Yeah?
Yes, sir. That is negative. Let's go.
It is negative. So MB is equal to positive all this, because we just moved this to the other side. 500 times 300, that'd be...
But it's a huge number.
Huge number. We'll get
Is it-
into why that is in a bit once I do this.
Is it like 22 million, right?
Yeah, 22 million. 22 million. 500,000 pounds. God. Pounds. That's not pounds. 500 pounds. Oh, that is way too big. Does anyone know a way we can just make this smaller? Because it's way too big.
Like write it as a smaller number, or
Well, just like reducing the amount. So what we can do is,
Make it tons.
yeah, KIPS.
oh, KIPS, right? KIPS.
Because you remember what KIPS stands for?
It's like 10 to the.
The
Yes,
1,000
it's
pounds,
equal
right?
like tons. It's the same. 1,000. So
So KIP is actually an abbreviation of kilo pounds. It's a kilo pound. See the KI right there? I'm actually gonna
Oh, kilo pound. Okay, this makes.
KIOP. You see KI from the kilo, P from the pound, KIP, and then KIPS, kilo pounds.
Wait, this makes so much sense because I know he just said like it was 1,000 pounds, but now I get why it's actually called KIP for like KIP. Okay.
So kilopounds, so we're just gonna divide by 1,000. So we have 22,500 pound KIP.
Imran, the KIPS
It's
is
actually
not
feet.
1,000 pound. It's around 2,000. It's 1,000 kilo, but the kilo is about 2 pound.
Oh, so the kilo, 1 kilo is 2 pounds, but
Okay, it's exactly it's so the pound is 450 gram. So
okay.
the kilo is 1,000 grams. So we're talking about 900 gram plus 100 to equal a kilo. So 2 pound is less than a kilo though.
Oh, okay.
I think what you're. Wait, Odie, do you understand this though? The kilo pound
Yes, yeah.
going from pounds to kips. Okay.
Yeah.
Because I thought I heard kilograms somewhere, but yeah, that's the.
No, I'm converting the pound to gram and the kilo to gram so he could understand it.
Right. So I get like the bigger context, but for this problem specifically, I get why we're going from 22 million pounds to 22,000 kip feet.
Yeah.
So basically, 1 kip is half a ton.
Can you repeat why it's negative that you put it with the 500?
Yeah. So
Yeah.
see how this is going to the right.
Uh-huh.
This wind is going to the right, and go to right. Remember, we're taking the summation of moments at B. So when it goes right, it goes clockwise around the point. So it's negative.
Okay. But why we decide to make it on the right, not on the left?
It doesn't say. I just put it on the left side. You can put it on the right, I
so it
think.
doesn't matter then though, right? Or something?
Well, it's all relative.
Okay.
Just like if your thing is if your wind load is going to the right and your moment is going clockwise, your bending moment is going counterclockwise, then you should get a positive thing.
Okay.
But it all depends on how you draw your diagram and how you draw the internal forces.
So that's why he did not give us a drawing, so we could some
Draw
people
it.
might
Yeah.
have on the left and they would have different.
Right.
So just pound feet. I wasn't thinking earlier. This is actually 22 million pound feet, pound times feet. Because remember, it's a moment. So it's a force times a distance.
Gotcha.
And then we took away the pound, and then we replaced it with the kip, and then we got that.
Well, there you go. That was number 4, right?
That was number 4.
And we finished the whole thing in less than 2 hours.
Less than 2 hours. Very nice.
So it's a new record.
Yeah, it's very nice. Go stop the recording.